All right, hello. Let's take a look at our first problem from chapter 1, in which we're given a density, asked to convert to specific volume, and then ultimately molar volume. Okay, so let's have some fun. Okay, so we're told that the density of liquid ammonia at 0 degrees Fahrenheit and 31 psi is 41.3 pounds per foot cubed. Okay, and so then in part A, we're asked to calculate the specific volume in feet cubed per pound, centimeters cubed per gram, and meters cubed per kilogram. Okay. So first thing to note is remember density, okay, is defined as being mass per volume. Okay. So my guess is in your Thermo 1 class, your mechanical engineering thermodynamics 1 class, you probably use a lot of density. Right? So density is defined as mass per volume. Okay. Specific volume. So specific volume, key being specific. Okay. So our specific volume, okay, V, okay, is going to be defined as volume per mass, okay, which is equivalent to 1 over the density. Okay, so our density is mass per volume. Okay, specific volume is volume per mass, which is equivalent to 1 over the density. Okay, density is an intensive property. If I were to cut my system in half, the density would remain unchanged. Likewise, specific volume is intensive. Okay, cut my system in half, the specific volume of those two halves are exactly the same. All right. So then in B, we're going to be asked to compute the molar volume. Okay, so the key is our molar volume, right? Molar volume. Now we're going to deal with moles. Okay, so as a departure from your Thermo 1 class, your mechanical engineering thermodynamics 1 class, in which you probably used a lot of density or specific volume, mass-based quantities. In this course, we're going to use moles a lot. We're going to be dealing with molar quantities. Okay, so you could have a molar density. Okay, and so let me just write it because it's not listed in the problem statement. If I want to compute a molar density, okay, our molar density, we just replace mass with moles. Okay, it's just moles per volume. Okay, now the molar volume, V, okay, is now instead of volume per mass, volume per mole. Okay, and that'd be equivalent to 1 over the molar density. Okay. Now, what's the relationship between mass and moles? Okay, so I should have open. Yeah, so I've scanned up online, the appendix from the text, and so in the first part I have some information on unit conversions, which will be useful for the first part, right? And so in terms of going from grams to kilograms and pounds to kilograms. But then going to the appendix, right, in the table A1, critical properties. So if I were to find ammonia, it'll give me the molecular weight of ammonia. Where are you, ammonia? Here we are, ammonia, right? Molecular weight of ammonia is 17.031 grams per mole it's listed as. Okay, so let me write down that the molecular weight, okay, of ammonia is 17, I'll just list it as 17 grams per mole. Okay, so the technical SI unit, if I'm not mistaken, of molecular weight is Dalton. Okay, so I could equivalently say that the molecular weight of NH3 ammonia is 17 Daltons. All right, so Dalton is just equivalent to grams per mole. Okay, so what is a mole? Well, Avogadro's number we know is equal to 6.022 times 10 to the 23 inverse moles. And so how you can interpret that is when I'm talking about something like ammonia, that'd be the number of ammonia molecules that are in a mole of ammonia. Okay, and so molecular weight, all right, 17 grams per mole. In a mole of ammonia, so if I have a mole of ammonia, so if I have 6.022 times 10 to the 23 molecules of ammonia, that's going to weigh 17 grams. Okay, so it's going to give us the conversion between molecules of ammonia and mass. Okay, so in general, if I want to, convert from mass to moles, all right, the key to doing so is going to be in my molecular weight. Okay, so you'll just have to keep track of units when you perform that conversion. Okay, cool. All right, now a couple of things that I found, tricky at first when dealing with moles as an undergrad is, okay, the official SI unit of molecular weight is going to be Dalton. Okay, and actually I should add another thing that you probably saw a lot in chemistry would be atomic mass unit, AMU. Right, so 17 grams per mole is equal to 17 Daltons, the SI unit, or often it's referred to as, in this case, 17 atomic mass units. Okay, and so if I were to calculate molecular weight using my periodic table, all right, I'm going to be thinking in terms of grams per mole. Okay, I like to think about grams per mole only then in terms of dealing with conversions. All right, but okay, to take things further, so what does this mean? If I had a mole of 6.022 times 10 to the 23 molecules of ammonia, this is how much it would weigh. Okay, well, okay, so molecular weight, well, I can write it as 17 grams per mole, right, or 17 Daltons. Okay, sometimes I want to deal with other units. Okay, so another way I could represent this is being 17. First, I'm going to say grams. Okay, and then historically, and I'm not sure if it's exactly in CGS units, but oftentimes a mole. Okay, mole is a SI unit. Okay, but historically, mole used to be written as mole as we know today would be written as a gram mole. Okay, so I could write this as 17 grams per gram mole. Okay, how I interpret this is when I look up molecular weight in, say, AMUs in my periodic table, and in my head I just get that as 17 grams per mole. By replacing mole with gram mole, it's remind me of the mass, the corresponding mass I'm going to use in, say, a conversion. Okay, but 17 grams per mole or 17 grams per gram mole. Okay, you might also see it as say 17 kilograms per kilogram mole. Okay, or more commonly it would be 17. I'm going to get the 17 in there for completeness. 17 kilograms per kilomole. Okay, or as relevant to this problem, 17 pounds per pound mole. Okay, it's all the same. Okay. Okay, so hopefully I haven't confused you or lost you yet. Okay, but you have to keep track of all these things. So this is 17 grams per mole, right, is equal to 17 AMUs. So if I wanted pounds per mole, okay, so this is 17 pounds per pound mole, right? It's a pound mole because it's telling me the unit of mass I would associate with this, molar unit. If I want to know the molecular weight, or if I was given, molar density in terms of moles per volume, and needed to get the mass in pounds, what I would first do is I would first use this. Okay, I'm a very simple-minded person, right? And so what I would first do is take, say, my molar volume, which uses moles, use this molecular weight to get to grams, and then once I have in grams, then I could do a mass conversion to convert to my favorite unit of mass. So hopefully I haven't completely lost you. Okay, but key is, from chemistry, you probably thought about AMUs. Maybe you've seen SI unit of Dalton when dealing with molecular weight. And then the other way I often think of this is grams per mole, where mole is my SI unit for a mole. But historically, right, you might see, mole historically was called gram mole, where the gram just tells us essentially the unit of mass that's associated with that molar unit. Okay, so we have gram moles, kilogram moles, and pound moles are all a possibility and come up in this problem. All right. And then the last thing I'll say before we play around with one of these problems, and so we'll do a couple of these, we'll at least set them up, is, so I said in your Thermal 1 class, you probably dealt a lot with mass-based quantities. Okay, so now, whether we deal with mass-based quantities or molar quantities, they're all the same, right? The conversion factor is just molecular weight. Okay, and so we're not really doing anything new here. Okay, it's just, we have a conversion factor which allows us to go from mass to moles. So I don't think we're doing anything new, crazy, or different. Okay, it's just, how do I want to put it, right? So, this is not a class in, intermolecular interactions, which I'll emphasize throughout. But, oftentimes we will try and think about what's happening at a molar level in our system, because any insight we can gain into our system, can allow ultimately to, kind of improved process designs. Okay, or allow us to better understand our system and design better processes. And so hand in hand with that then is thinking more about molecules rather than mass, right? How many molecules do I have in my system per unit volume as compared to mass? Okay, but that's a complete aside. All right, so let's set up these problems, and then you can crank through them for homework. Okay, so again, we're given density in pounds per foot cubed, and then you're asked to compute specific volume, foot cubes per pound, centimeters cubed per gram, and meters cubed per kilogram. Okay, so let's write it as this. Okay, so we're given. Okay, and I'm just going to write it as rho, and we can write it. So we'll do full units. So we have the density, and was it 47.7? 41.3 pounds per cube. 41.3 pounds per foot cubed. Okay, so in A, okay, we want the specific volume in units of foot cube per pound. Okay, we were asked for foot cubed per pound. Okay, centimeters cubed per gram. Okay, or CGS units, and then also meters cubed per kilogram, which would be our SI units. All right, so how would we do this? Okay, well, remember, volume is nothing more than, specific volume is nothing more than 1 over density. Okay, so if I want, if I'm given pounds per foot cubed, well, my specific volume in feet cubed per pound is just 1 over that. All right, so, V, I could write as 1 over 41.3, and that's foot cubed per pound, right? Would be the first one, right? And you can actually perform the numerical calculation. Okay, then from there, centimeters cubed per gram, meters cubed per kilogram, I'm going to have to look up the appropriate conversion factors. Okay, so if I wanted to get from here to centimeters cubed per gram, well, let me look up the conversion from centimeter or foot to centimeter. Okay, so again, I'm going to the appendix I have scanned up. Okay, and in chapter 1, they contain a table with some conversion factors. Any table that you have is perfectly fine. So we have 1 foot is 0.3048 meters, where 1 centimeter is, so 100 centimeters we know is 1 meter. Okay, so let's work out the conversion then. So I know that 1 meter is 0.3048 meter. Okay, I got it messed up, right? So sorry, 0.3048 meters. Okay. Oop. Ah. Okay. Is equal to 1 foot. Okay. However, I need cubic feet. So if I were to cube the bottom and cube the top, I'd have this cubed, meters cubed is equal to 1 foot cubed. Okay. So to get my unit of length to meters cubed. And then I know that 1 meter is 100 centimeters. Okay, so again, if I were to cube the top and bottom, I'd have 100 cubed. Centimeters cubed is 1 meter cubed. Okay. So now I have my desired unit of centimeters cubed. And then I would just need to take care of mass. So mass, 1 pound is 0.4536 kilograms. So 1 pound's on the bottom. So 1 pound is 0.4536. Okay. Then SI, I know that 1 kilogram is 1,000. Sorry, I'm running out of page here. This is 1,000 grams. Okay. So that would kill. So pound gets killed here. Kilogram gets killed there. And I'd be left with centimeters cubed per gram. Okay, so it's just a matter of using your table of conversion factors to perform said conversion. This one's just complicated because we're given a density to begin with in English units. And so typically, you've probably in the past have mostly just seen SI units. But conversion's not a problem. Okay, so that's gives you your specific volume. Then in B, we're asked to get our molar volume. Okay, and it's going to be, analogous. We're going to be looking at, let me see, did you want pounds? Pound, mole, and then notice these later two just use moles. Okay, again, mole is my SI unit. So we want foot cubed per pound mole, and then we want centimeters cubed per mole, and then meters cubed per mole. Okay. All right, so how would I do this, right? Our conversion factor is just going to be our molecular weight, which we looked up here was 17. Okay, so my molecular weight, okay, is equal to 17 AMUs, which is equivalent to 17 Daltons, 17 grams per mole, okay, or relevant to this problem, 17 pounds per pound mole. Okay, now I'm not going to write kilograms per kilomole or kilogram moles because in the second one, I want moles, not kilogram moles or kilomoles. Okay, I just see I have pound moles and moles. Okay, so I'm just going to write this in terms of grams per mole and pounds per pound mole. All right, so how would I convert? So let's see. So we knew that, say, our specific volume, okay, I'm going to write as 1 over 41.3. Okay, and that was foot cubes per pound. Okay, so if I want foot cube per pound mole, okay, and my molecular weight's 17 pounds per pound mole, okay, well, I would just multiply by molecular weight in this case, right? Where I have, so let me box or put this in parentheses, so that times 17 pounds per pound mole. Okay, some pounds would cancel, and I'd be left with foot cubes per pound mole. Okay, that's it. Okay, so let's imagine that we had calculated my specific volume. Okay, and I'll write this as an X. If I'd calculated my specific volume in centimeters cubed per gram, okay, and I wanted centimeters cubed per mole, again, I would just multiply by my molecular weight, right? Molecular weight's 17 grams per mole. So I would just multiply by my 17 grams per mole. Grams would cancel, and I'd be left with centimeters cubed per mole. Okay, and then the last one you're asked for meters cubed per mole. Okay, and so how I would go from meters cubed per mole is actually I would take this one we just calculated, which is centimeters cubed per mole, and then convert centimeters cubed to meters cubed. Right, so I know 100 centimeters is 1 meter. So 100 centimeters cubed is equal to 1 meters cubed, right? And then that would get me units of meters cubed per mole. Okay, cool. All right, and it's just keeping track of all this craziness. I could have used 17 kilograms per kilomole, and and use my meters cubed per kilogram, right? Because we would have had meters cubed per kilogram. But then I would have had to still bring in that factor of 1,000 then. And so actually, let me just tell you, let's just show you so you know exactly what I'm saying. So if I had V in terms of meters cubed per kilogram, okay, and again we want say meters cubed per mole. Well, I could multiply by my molecular weight in terms of kilograms per kilomole. Okay. Okay, and so kilograms would cancel with that. And then, since I wanted moles, well, it'd be, 1 kilomole is 1,000 moles, right, in terms of SI prefixes. Okay, and that's that. All right. Hopefully you're able to get the problem. If you have any issues, just let me know.